Hi, this is Jeff Heaton. In this video, I'm going to show you how you can influence GANs. GANs, generative adversarial neural networks, are great. You can generate faces, you can generate cars, you can even generate cats. Okay, so nothing's perfect. But in this video, I'm going to show you how you can use example images to generate new images that share some of the features of the original one. So you can create random people that have glasses or do not have glasses. I used this for a Kaggle competition, Kaggle in class, that I ran for my students. I asked them to write a classifier. Can you tell if somebody has glasses or if they don't have glasses? That turned out to be a fairly easy Kaggle competition, but the technology used to generate the data set is somewhat interesting, and you may want to use this to generate specialized faces of your own. To see all my videos about Kaggle, neural networks, and other AI topics, click the subscribe button and the bell next to it and select all to be notified of every new video. So this is a Kaggle competition that I ran for my class, Introduction to Deep Neural Networks at Washington University. By the way, all the material and videos from the class is online, so definitely check that out if this is the kind of thing that would interest you. But let me show you how I generated the faces for this. What I was trying to do here is I wanted a data set that had people with glasses and without glasses. Naturally, I used GANs to do that. That's the greatest source of faces that you can come up with, and you don't have to ask the people permission. They're virtual. I generated, with my program, quite a few different varieties of glasses. You had shades, sunglasses, you had thicker frames, very thin frames in the case of this lady here, and a variety of others, even translucent frames like these that are somewhat sunglasses-like, but you can still see the eyes behind them. Now, this turned out to be a very easy Kaggle competition. I won't talk too much about that, but basically it was a small data set, and you could easily just go through the 500 or so images in the test set and self-label. As you can see, lots of people got perfect 0.0 scores, which should be impossible given that there is noise in this data set. All right, let's look at the program to do this. Okay, this is my GAN Underbar Explorer notebook that I have in my YouTube videos. I have a link to it for you in the description of this YouTube video. There's also a link to the video from here, but what I'm going to do is go ahead and open this in Colab, because this uses GAN2 from nVidia, and you need a GPU in order to run this, and Colab gives you a GPU. You'll notice I am using Colab Pro, not at all a requirement to make this successfully run. So here I'm going to show you how to generate GANs with potentially desirable features like glasses. You could also use this technique to generate, say, males and females and try to classify between that. GANs with headwear, other bling like glasses like I did, eye colors. It's really completely up to you. I have a link to the Kaggle competition that I ran for my students that I just showed you. Let's go ahead and make sure the runtime, change runtime type. You should be using a GPU. This also assumes TensorFlow 1.x, so I put this command into here. Now, don't give me grief about using 1.x when 2.0 is out there. I'm a big fan of 2.0, but nVidia has not updated this. This is GAN2, so GAN2 uses TensorFlow 1.x. So that is what you must use if you want to do that. The notebook was not authorized by Google, so you can trust it. Just kidding, but it is my notebook, so I trust myself. You can choose if you want to trust me. I'm a pretty good person. I'm going to go ahead and link into my Google Colab or my G drive so that I can save these files. So a variety of things you might want to do with these files, so it's good to be able to write them to G drive. So I've entered that. It's connecting my G drive to Colab. Now these virtual machines that Colab uses start up completely anew each time. So here I've got to check out GAN2 from GitHub. And now that I've got that, I can see that it's there just to verify. And it's there, it's available. If you run this code, you can now import DNNlib, which is GAN2. All right, we have it there. This is some code that I copied from nVidia. I've modified it fairly heavily, but it is originally nVidia's example code for how to use their GAN2. Basically what's going on is A style GAN is generated from a 512 number vector. That's a big, giant amount of numbers and hard to deal with. So what the nVidia style GAN2 paper did is they created seeds. So a seed generates the latent vector, that big 512 number vector, and then the big latent vector is used to actually generate your image. So the seeds can be small numbers. You could use 0 as your seed if you so desired. But these seeds are then used to generate a random 512 latent vector. We use the seeds just as starting points, but to do anything interesting, you've got to use the latent vector. Because if you have a seed of, say, 1000, and you go to seed 1001, they will look completely different. So what we do here is we expand the seeds. This expands a vector of seeds into the 512 number vector. Now the 512 number vector, those big giant arrays of numbers, I mean 512 is not that big, but still it's hard to wrap your head around 512 dimensions. If you change, say, just one of those vectors by a small amount, the face will change ever so slightly. You will not be able to tell really the difference. If you take two vectors for one face and the other face, and then you slowly move the first vector to the second one, slowly mathematically transforming it until it gets to the other one, you can do these really, really cool morph sort of effects to morph one face into the other face. The fact that those latent vectors, that small changes that just affect the style, is why style GAN is called what it is, and it lets us do some really neat things. This function here that I wrote based on NVIDIA code, GS is just the neural network that you're going to use to generate these. This is your list of seeds. However, these are really the latent vectors that came out of this. I probably should have called that latent vector, but I think of the latent vectors almost as seeds themselves. And then truncate PSI. This is essentially letting you define maybe small changes to an actual image. I don't really use this in the process, but I let it be passed. You can fine tune the images a bit with that. And then prefix. This is just the file name, because basically it's going to generate these images and write them out to some location on your disk. In this case, it's going to write them to Google Drive. I'm not going to get into this code too much. This is just code that I took right from NVIDIA that is setting up their library so that you can generate faces for it. This loop I wrote here, basically the list of seeds that you have, it's going to enumerate them so that we have a counter, and then we also have the seeds, and it's going to generate each of these seeds going all the way up to however many you asked for. This is going to be useful because I will generate a bunch of these seeds at once. I'm going to go ahead and run this block so that these functions are defined for me. This code is going to load the weights for the style GAN so that we know that we're generating the faces. There's other ones that you can load too, and you can generate cars and churches and even cats, horses. This takes just a moment to run, so I'm kind of fast forwarding through this. Okay, that's complete. So the first thing that I do is I run this code here. And I'm going to go ahead and run it. It starts from a fixed seed. I'm picking 9200. Let me run this just so that we can get through this, because this takes potentially a little while. But I am starting from 9200. It's going to write out files. So 0 will be 9200. And it essentially generates those. And I'm having it show the faces here. These faces have no connection to each other whatsoever. They're just seeds that occur next. So you can see from the seeds that NVIDIA generates, there's quite a few different ones. Now, that one's a child. So maybe I wanted to write a program that generated just children. Maybe I wanted to be able to see if you could tell between children and adults. That might be a fun Kaggle for my class in the future. But these are the faces that it's generating. And it's giving you the seed there. So 9213 for that person, 9214 for that person, 9215, and so on and so forth. That one has a GAN mutant over there. and so on and so forth. So what I'm doing here is I'm just generating a bunch of images. The more images you generate, the higher quality you're going to be able to create for the features that you want. Now what you do with these is you go through and you write down, or copy and paste, whatever you want to do, the seed numbers for all of the images that share the particular trait that you're looking for. So if I was looking for images that had glasses, I would just scroll through these random ones until I found somebody with glasses. Looks like more people don't have glasses than do. This guy has very thin glasses, but I would write him down. And you come up with all those numbers as you look through more and more and more faces. So this will go through for a certain amount of time. Since these are seeds, it's entirely reproducible. That same seed will always generate the same face. And notice I'm calling the expand seeds here so that we basically have the full image vector so that we can generate it using the latent vector. Let's go past this. Let's go to the next part. This is something that I use to just view a single seed. 9208 would generate her, and if we run it here, it should generate her. Yeah, so see, that's just a little test area. You can use that to play with the seeds and just see what they're generating. So what I'm doing with this part here, this is not perfect, but it works pretty well. So what you might see is here. So if you look at my Kaggle competition, Kaggle's kind of gray in it, so it's not real clear, but this gal and this gal look like pretty much the same person, except glasses and no glasses. So I wanted to get a image that was glasses and not glasses that looked like the same person. So the way that I did that is I started with somebody like this person here, the 922. I think that is the person that I had there. So I'm going to run this, and I'm going to let it run just so that it starts generating some. What it's doing is it's going from 0 to 500. So it's ignoring the last 12 of these values. And what this is doing is it's adjusting batches of 10 by a decent amount. So it's moving them by -2. That's purely arbitrary. I'm just monkeying around with different parts of the vector and seeing if I can get the glasses to disappear. And you can see it's generating quite a few faces. So this is letting me know, let me scroll that all the way to the top because there's quite a few people. Now you might be tempted to think with those 512 values that maybe it's like a genetic sequence and maybe one of those governs if there's glasses or not. That doesn't work that way. That would be like thinking of the latitude and longitude on the Earth and trying to write a predictor that predicted, given a latitude and longitude, how high is the mountain there? How high above sea level are we? Now, just thinking about planet Earth, that is nonsensical because the latitude and longitude bears no possibility to how tall or how high something is. Maybe you could use latitude to predict the temperature to some degree, but you have to think of basically the search space that we have for all these faces is very rugged terrain that we don't really know. We just know that, okay, if the sea level above is pretty high at one latitude and longitude, near that latitude and longitude, it's going to be pretty similar. And if it starts to decrease, it'll probably continue to decrease. That's all we can do here. And this is basically what we're trying to do. So now I'm just trying a random sample here, and I'm basically trying to get her glasses to disappear. All right, still there, still there, still there. Gone. Okay, that's useful. So messing with positions 30 through 40, I'm able to remove her glasses. Still has glasses there, still has glasses there, but notice too the head position shifted. So that might be another trait that you're looking for. Maybe you're wanting people just facing in one direction. Okay, so now I copy in the 30 through 39 for that person and I run it. It should generate exactly that same person that we saw above without the glasses. Now, which of these changes are actually causing the glasses? Because this will allow me to move it even closer to having those two people look the same except no glasses. So I commented out half of those. Okay, the glasses came back. Let's take out those 3 and run it. And not that they have to be in order. This is not a perfect process. There, her glasses are gone. So we needed those 3. So let's try to comment out some more. maybe those two. Completely random walk. Random walk with my slight intuition. Glasses came back, so it was one of those. Glasses partially there. So why not? I'm going to call it. That's close enough. So this is how you would get somebody with glasses without glasses. She's also got a GAN twin going on, so you may or may not want that. Now, let's try to generate the data for something like my Kaggle competition. So here what I'm doing is I run this code just to get it ready so that we have that. Glasses and no glasses. What I'm doing here is basically getting the people in that data set. So I ran this for seeds 0 through 1,000. And I used my human intellect, which is not that great, but it works, to pick which ones of these had glasses. Now the ones that were not in this list don't have glasses. So I have these two sets. Let's go ahead and run that so that's defined. Now what I'm going to do is the generation set is glasses, so we're assuming that we want glasses. Now you might be generating males and females, children and adults, hats and no hats, however you want to do it. You would just hand pick these out of that first set that you have generated. I generated 1,000 of these, put them into a directory, and just zipped through and manually classified them. That's why people were getting perfect scores in my Kaggle competition, because I said don't hand classify them, but nobody ever listens. So people were, I don't know, cheating is too strong of a word, but if you want to generate them, this is the way to do it. It didn't take me that long to go through 1,000 images and hand classify them. Now when I'm going to go ahead and run this code so that it is in fact running. And what this is doing basically is it's going through the count. So count tells it how many you want it to generate, which is down here, so 5,000. Now I need to move this around a bit so that it does actually generate them. Okay, let's look at how this code actually works. This is going to generate a set. It's just going to generate the seeds. It's not going to generate the actual images yet. So I'm going to loop through however many I'm asking for, and I'm going to pick from the generating set. So I'm going to pick 2 people that have glasses each time. I'm going to extract the latent vector from each of those 2 people that have glasses, and then I am basically going to pick a point right in the middle of them with some degree of randomness. So it's going to be near the midpoint between these 2 high dimensional vectors. So that's not just a simple number midpoint, it is 512 vector midpoint between those 2, and generate some variance there so that I'm not always picking the exact midpoint. And this is how I basically step it to that point. And I also rounded these, mainly because I was wanting the students to analyze the latent vectors as well, so that made them not these big giant decimal place numbers. And I return that slightly offset center point between the 2 people with glasses. So that's how I'm doing it. I'm randomly picking constantly from my stable of people that have glasses, almost breeding them, so to speak, knowing that a person halfway between them, plus or minus that median area that I allow for the variety. Otherwise, I would only be able to generate every possible grouping of 2 people as we loop through this. So this gives me the ability to generate quite a few different people. Now I'm going to run this, and it just generates initially that data frame. Here I was concatenating them together. I'm not running the non-glasses right now just for this explanation, so I just temporarily... This part just saves the CSV files that I was using for my competition. I'm going to go right here and actually generate it. So you can see we have 3,200 people. It's 514 because I also added the label and an ID number, which is typical in Kaggle. I'm going to run that. And now it is generating quite a few people. These people should all have glasses. Let's go to my G drive real quick and verify it. Now this is generating this off to my content directory, so I can't really go and view them yet. What you have to do to actually see them is go in and zip them up so that we can save that. I'm not going to let this thing run completely to completion. All right, there you see it. Image is zipped just where I zipped it to. I'm going to download. I don't care about viruses and PNG files. We'll fast forward as it downloads. All right, let's decompress it. And here are all the faces, and you can see they all have glasses. Now, this is not perfect. Sometimes you will see somebody that does not have glasses in here. It doesn't work perfectly, like her. Think about how this is working. Say I picked all the mountain tops on planet Earth, and my approach was maybe I had 100 of these, and I took these 100 mountaintops and I chose 2 random ones and then did kind of a midpoint between them. There may or may not be a mountain there, but considering many of these might be on the same mountain range, you're going to have a greater chance of getting getting another mountain in between the other 2 mountains. Now you might end up with a valley between, or you might end up with 2 on completely other sides of the planet. If I wanted to refine this a bit, what I would probably do is make sure that I chose 2 vectors that were reasonably close to each other. I bet the 2 random vectors that I chose to generate this person, while her parents, so to speak, both had glasses, I bet her parents were so far apart that the point that I picked in the middle was simply somebody that did not. But nonetheless, this gives you a pretty high probability that the people you're generating will have the trait that you want. Thank you for watching this video, and if you found this useful, please give me a like and subscribe to my YouTube channel. Thank you very much.